Question 5 says a block of ice, mass 10 kilograms, is pulled 20 meters up a smooth plane inclined at 45 degrees to the vertical. The block of ice is initially at rest and reaches a velocity of 2 meters per second at the top of the plane. Calculate the magnitude of the force required, assuming it acts parallel to the plane. So, as ever on these, I think it's helpful to draw a diagram. Hopefully the previous questions are going to help us answer this one, where we have to do a bit more. We've got a block of ice that at time 0 is at the bottom. It's initially at rest, so we might record that down here. And it's got a mass of 10 kg. It's pulled 20 meters, so this distance here is 20 meters up. When it gets to the top, it's traveling with a speed v equal to 2.0 meters per second. And we're told it's a smooth plane. I think we're able to assume that the friction throughout is equal to 0 newtons. So that's the setup of the problem that we're looking at. So we've got we're going to work out the energy changes that happen in this situation, use those energy changes to work out the work done, and then knowing the work done, we can see what force has to act through this distance. So there's 2 energy changes at the start. We're going to say it has 0 gravitational potential energy and it has 0 kinetic energy. But by the end, these are both not equal to 0. So we need to find the size of both of these. So let's start with the kinetic energy, because it's the easier one of the two. Half mv squared, which is equal to a half times 10 times 2 squared. So 2 squared is 4, half of 4 is 2, so this is just 20 joules. And at the end, its gravitational potential energy is equal to mg delta h. So the h it moves through is this vertical height here. As we've seen previously, this we can get from using a bit of trigonometry. So the sine of 45 should equal h over 20, which means h should be equal to 20 sine 45. So this should equal to 10 times 9.81 times 20 sine 45. Which is 1,387. Significant figure-wise, we're going to end up working to 2, aren't we? There's a good clue there that it's 2. So 1,400. Well, I suppose we should be careful with significant figures. So the value that I had at the start for half mv squared was relatively small. So let's keep it to 3 significant figures. I'm going to say 1,390. I'm going to write this value down. So the total work done is 1,390 plus 20, so 1,410 joules. And therefore we can say, since the work done is equal to the force multiplied by the distance, that the force should equal the work done over the distance. So that is 1,410 divided by 20. Which comes out as 70.5. So we're going to label it as 71 newtons.